Welcome to our presentation of the paper titled Forming and Controlling Hitches in Midair using Aerial Robots. We propose a novel way to interlace cables to form hitches. This method has application in securing objects for aerial transportation. Cables are versatile and lightweight and have the potential to replace heavy mechanisms that are being used in robotics literature. Also, current methods in aerial cable manipulation still require human intervention to secure objects. Human interlace cables to form hitches and nuts for multiple purposes, especially to tie, hold, and carry objects. We found interesting physical hitches, such as packing hitch, marine hitch, and single diamond hitch. All of them used multiple cable intersections to hold objects. The hitch is defined by a polygon, making it versatile and adaptable to a wide variety of objects. And depending on the cross-sectional object shape, we can choose a convex polygon, such as a triangular hitch, a square hitch, or pentagon hitch, and so on. Now consider a team of catenary robots, where each robot is composed of two quadcopters attached to the ends of a flexible, not stretchable cable. The catenary robots can interlace their cables by passing along each other. We want to use end catenary robots to interlace their cables and form a hitch with the shape of the polygon P. The configuration of the polygonal hitch is determined by the location of the quadrature QK and RK and the vertices of the polygon PK. A vertex is formed by interlacing two cables, and it forms an H shape with four tensions. We analyze the tension at the kth vertex to be an equilibrium force, and the k vertex at the location pk is in equilibrium when all the tensions add up to zero, meaning that the following equation has to be satisfied. Given the polygon P, the direction of the kth edge of the polygon pk and pk plus 1 is denoted by the unit vector uk. The position of all vertices are part of the input, so the vector uk and uk minus 1 are known, but the tension tk and the cable orientation q hat k and r hat k minus 1 are unknown. In order to find a practical solution for the equilibrium equation, we consider a special case where all the cables have the same tension and the cables are aligned with the polygon edges. We present four actions that allow robots to form a hitch and change its shape in mid-air. Assuming a quasi-static motion, we compute robot positions and trajectories. Our method works in open loop and only uses the localization of quadrotors as a feedback. In action 1, we propose a method to form a hitch by interlacing cables. First of all, the quadrotors move to the starting point. Then, they swap position with a circular trajectory between QK and RK, creating an intersection. Finally, the robots complete the polygonal hitch. In addition, action 1 can be used to untie the hitch. We also successfully formed a hitch with four vertices. The steps can be run in parallel, allowing hitches with a large number of robots to be formed in constant time. Here, we are focusing on moving a single vertex to demonstrate that the polygonal hitch is able to control an intersection point. We perform an experiment where the point P1 is moving along a linear trajectory, while P2 and P3 remain static. The third action shows the ability to move an edge. Also, this is possible applying the action 2 twice. The last action that we discussed is adjusting the cable length. This action is helpful after moving a vertex or an edge. In this work, we propose a novel class of hitches that can be formed and morphed in midair using a team of aerial robots with cables. In future works, we aim to transport objects and include the cable dynamics involved in our system. Also, we want to include the cable position to perform a control feedback from its shape. Thank you for listening us, and we are happy to respond any question.